Okay. And moving on with section B, question 21. A curve has equation y equals 3x squared take x cubed. Find the coordinates of the stationary points on the curve and determine their nature, and state the coordinates of the points where the curve meets the coordinate axes, and sketch the curve. Okay, so moving that to one side, here we have my answer to this. Okay, question 21. So we have y equals 3x squared take x cubed. We're going to get the stationary points. So the first thing we do is we're going to differentiate. 2 times 3, 6x. So 3x squared differentiates to 6x. Differentiate x cubed, you get 3x squared. Point out that you know the situation for reconciliations, that is that dy by dx has to be 0. So set 6x take 3x squared equal to 0. We're going to take, let's say, 3x out as a common factor there. So 3x times 2 take x gives 0. 3x times 2, 6x take, yeah, that's fine. So we have two things multiplying to give 0. So 3x is 0, so x could be 0, or 2 take x could be 0, which would mean that x would have to be 2. Now when x is 0, y is 0, y is that formula there, so putting 0 through is quite simple. And when x is 2, 3 times 2 squared, a little bit of work there, you might not need to do that, you might be able to do it in your head. 3 times 2 squared take 2 cubed, 12 take 8, that gives you 4. So we have stationary points at 0, 0, the origin, and 2 along, 4 up. Let's find the nature of them. Are they maximums, minimums, point of inflections, or what? Okay, so here we have our x values leading up to our first stationary point at 0, going from 0 to 2, second stationary point, x coordinate of it, and what happens after that. Now I've picked x to be minus 1 there, and x to be 1 from 0 to 2, and bigger than 2, I pick x value of 3. So I'm going to work out the gradient of the curve. When x is minus 1, don't forget dy by dx is 6x take 3x squared, so we just put that through that formula and you get minus 9. Obviously, when x is 0, the gradient is 0 because it's a stationary point. When x is 1, we have a gradient of 3. 6 times 1, take away 3 times 1 squared. Don't forget what dy by dx is. That gives you 3. And when x is 2, we have a stationary point, of course, at 0. And when x is 3, 6 times 3, take 3 times 3 squared, that gives you minus 9. So, negative gradients go down, 0 is flat, positive gradients go up, 0, minus 9. So when x is 0, we have a minimum, and when x is 2, we have a maximum. So we have a minimum at 0, 0, and a maximum at 2, 4. Part B, just to remind you, state the coordinates of the points where the curve meets the coordinate axes and sketch their curve. The coordinate axis, of course, is just the xy axis. Okay, it meets the y-axis when x is 0. So when x is 0, put that through the formula for y, and obviously y is 3x squared take x cubed. We have 0, 0. We could have known that anyway. And it meets the x-axis when y equals 0. So don't forget, the formula is y equals 3x squared take x cubed. If y is 0, we have 0 equals 3x squared take x cubed. Take x squared out as a common factor here. And we have x squared times 3, 3x squared, take, yeah, x cubed. So we have two things multiplying to give 0. So x is 0. And x is 3. So these are, the other word for these are called roots. So we have 0 there and 3 there. And there's our turning point of 2 along, 4 up. That's it there. So we can now get a fairly good idea. And of course, this nature table gives you a fairly good idea about what the curve looks like. So here we have it here. Coming down, turning point at 0, 0. Going up, I worked out 1, 2, just as another point, just to guide me. When x is 1, I worked out the y coordinate of 2 there, just to guide me a little bit going up there. Turns, back down, through 3, and that's a graph of the function.